Okay, 6-4.
It's not showing it.
That's no good. Alright.
Don't even have the HDMI button.
Back to business here. Okay. Now we can see. So 6-4, equivalent fractions. I'm looking at page 184 and 185. So quiz tomorrow on our first 4 sections that we had, rules of divisibility, prime and composite numbers, making the factor trees, and then this. Each of the lessons are a bit different from each other. Chapter 6 is all about kind of reviewing all the things we need to be able to do with fractions to actually do order of operation stuff, add, subtract, multiply, and divide with fractions and mixed numbers. So chapter 6 is all about all that we need: greatest common factors, least common multiples. We need to write fractions with same denominators. We got to simplify stuff. We got to turn improper fractions to mixed numbers, vice versa. Lots of different maneuvers here. So the factor tree stuff, we did that yesterday, yes. Today's lesson has nothing at all to do with factor trees at all. So we don't need them at all today. But tomorrow, once we get through our lesson and start greatest common factor, we will return to seeing, you see the trees there, so we're coming back to them. But for now, they're just kind of off to the side. The objectives were that you could identify differences between prime and composite numbers, which use that information to ultimately make the factor trees, which you did. All your trees are good. I think you're strong with this here. So we'll be in good shape when we need the trees for an actual purpose. What do we do with the trees? How do they help me? Well, that's what we're going to find out tomorrow. So equivalent fractions. Honestly, I don't think this will take long at all. I don't want to waste all our time here. So number 3, I'm just going right to them here, page 185. What we see is something that looks like that right there. And if we look through the page here, it's very similar throughout the whole lesson, what we're going to be doing here. I would also think if I wasn't even here and nobody taught you, you would probably just figure all this out here without too much difficulty. But we need equivalent fractions primarily for when we add and subtract fractions. We need to get that common denominator, and then we have to rewrite fractions so they have that same common denominator. To do that, you have to be able to write equivalent fractions, where they are equal to each other. So equivalent fractions are equal. I will illustrate that concept here real quick. So, take for example, we'll just say a pizza. All right? And if we cut the pizza in 2 pieces here, and you get 1 piece and I get 1 piece, how much of the pizza did you get? You got 1 of how much? How many total pieces? Right. You basically got half the pizza. People understand that, right? Good. 1 for you, 1 for me. But say I have another pizza, all right? I cut it into 4 pieces. I get 2 pieces. You get 2 pieces. So how many pieces did you get? Of the how many? 4. But if I divide both of these by 2, which is the rule that we're going to learn today, this is still more or less you got half the pizza. I get 2 and you get 2. You got half, I got half, right? Do you agree with that? And I can continue on here. I could cut it into 6 pieces where I get 3, you get 3. But still, I mean, if there's 6 pieces, you get 3, I get 3, you get half, I get half, right? They're all the same. Those are equivalent fractions. They're all the same. They may have different numerators and denominators, but this one here, if I divide both of these numbers by 3, I end up right back to where I started, right back at 1/2. So, rewrite it, it's kind of up there a little bit. To write equivalent fractions, this is the whole deal here. You can only use multiplying or dividing. No adding or subtracting here. but you need to find a rule. So you're looking for, in the fraction here, the line, the numerators or the denominators, where you know both the numbers. Do I know both the numerators or both the denominators? I know both the denominators. So that's where I can establish my rule. So I was at 4, I ended up at 12. How did I get there? Multiplied by 3. And whatever I do, if I multiply by 3 on the bottom, then I have to do the same thing to the other side of the fraction. And if I do, the fractions are equivalent. They are equal. I have not changed them. So what is 3 times 3? And that would be what's on top there, 9/12. 3/4 is equivalent to 9/12. And I could go backwards too. If I said, what's this? Well, you would look at it, and I started at 12, I ended at 4. How did I get there? I divided by 3, and if I divide by 3 this way, then to make it equivalent, I need to do the same rule, order of operation to the other side. What's 9 divided by 3? And we're right back to where we started the whole process. So that's the whole thing here. If you're able to do this, and we'll use this skill extensively when we're adding and subtracting fractions. As you remember, we'll have to get common denominators. To do that, we need to figure out what the common denominator is, and then do this, write an equivalent fraction with the denominator that we want. Make sense? All right. I'll put a couple, and then I'll give you guys a few, but number 5, 2/9 equals C over 81. And 18. 4 over K equals 20 over 25. So number 5, what's C? Solve for C. Number 18, you're solving for K. What's K? Okay, both of these, the variables in very different spots. This one, it's on the right side on the top. This one, it's on the left side on the bottom. And that's totally fine here. I mean, you could see it on either spot. That's totally fair game here. Top, bottom, left, right. So it's still about making sure we figure out the rules. So for here, I'm trying to figure out how did I get from this direction. I want to go from 2 to something. So how did I get from 9 to 81? Well, I had to multiply 9 times 9 to get to 81. So now I know what my rule is, or what I need to do to be equivalent on top. Do the same thing on top. 2 times 9, C should equal 18. That one. For number 18, again, we're solving for K. We're going this way here. So our rule needs to go the direction we want it to go, because I know 20, and I ended up at 4. I could certainly, if it helps, rewrite it this way. There's nothing wrong with this. The rule's not going to change here, but whatever I'm doing, I am dividing by 5. I started at 20, I ended up at 4. How did I get there? I divided by 5. So same way this way, what's 25 divided by 5? K should equal 5. And again, you can rewrite it this way, where I just flip the order if you like. Some people like having a variable on the right, but it's the same rule here. 20 divided by 5 is 4, 20 divided by 5 is K. So easy enough. All right, give you guys some to do. Yep. Number 10, 3/11 equals 6 over V. Number 13, 9/30 equals M over 10. 20, 49 over E equals 7/8. And 21. X over 15 equals 36 over 45. Those four. All right. Number 10, oh, one seg. 10 will be Damien. 13 Sierra. Evangeline. Jackson. All right, Damien, you ready?
think so.
All right. So, what's the rule I need?
The I don't
How did I get from 3 to 6?
well, you probably multiplied
By?
2.
Right. So then on the bottom, do the same rule.
You multiply 11 times 2,
Yep.
and then you get 22.
And that's what.
V equals 22.
Yes, sir. Good job. All right, Sierra, what's my rule?
Division
Yep, by.
30.
Right. So got it from here to here, divided by 3. 9 divided by 3 is?
3.
Right. It was 3. Good. Evangeline, what's the rule?
Division
By?
7.
Yep. So there's the part I know. Or actually, I should probably, we're going the other direction here. What did you get for E?
56.
Right. So
You have to multiply.
going this way, multiplying by 7. Right. So E does equal 56. Right. Good. Jackson?
Okay, so we're doing multiplying. 15 times 3 is 45.
Yeah.
So what times 3 equals 36? 12 times 3 equals 36.
Right.
So x equals 12.
Right. Yep. So this is kind of one of those fact family deals. 15 times 3 is 45. 3 times 15 is 45. 45 divided by 3 is 15. 45 divided by 15 is 3, where you can kind of rewrite, figure out the rule a couple different ways. of how you want to apply it. You go this way, figure out times 3, go that way, divide by 3, but just for simplicity purposes here, I'll put it this way, but x does equal 12. That is correct here. Okay. Good with that? Yes. Okay. Next part here, write 2 equivalent fractions for each fraction. 23 5/9, we've done this before. So there's unlimited equivalent fractions to this, to be honest with you. I don't want to do 5/9, I want to do 3/5. Ironically, I just created another problem with 5/9, so totally coincidental. So unlimited equivalent fractions of 3/5. You make up any rule you want, multiply, divide, doesn't matter. If I multiply each of them by 6, I would have 18 over 30. If I multiply each of them by 4, I get 12 over 20. Yep. Or, yeah. Multiply by what?
1.
Well, not by 1, that wouldn't be equivalent. It would be the same fraction. You know, anything. 10, 30 over 50. So there's 3 of them. You only have to list 2. So, but unlimited answers here. So it's just you make up a rule, apply that rule to both the numerator and denominator, and you're done. So I'll give you one to try. Why don't you try number 29, 11/15. Write a couple equivalent fractions. Anybody want to volunteer one of their equivalent fractions? Jackson?
33/45.
Yep, I'm guessing you multiplied everything by 3. That works for me. Anybody else got one?
11 over 30.
Not 11 over 30.
Oh, whoops.
I would take 22 over 30.
Yeah, 22 over 30.
There you go. Yeah, I like that one. 11 over 30 is not so good. What do you got, Dom?
55 over 75.
So he decided to multiply them both by 5. 11 times 5, 15 times 5. That's good. On and on it goes here. So, if anybody else wants to throw one out there, great. Otherwise,
44 over 60.
44, right? Multiply everything by 4. 44 over 60. By 100. 1,100 over 1,500. So, all right, last part is more of the same. They don't really give the best examples here, nor do they take them out too long, so I'll create an extra one here. But it's essentially creating 2 equivalent fractions, so number 33. Says 1/3 equals x over 6 equals y over 18. And basically I'm doing the same thing we did at the beginning, except now I need to solve for x and y. They're all equal to each other. So best way to go about solving these is just treat it as 2 separate problems. Just do what you did in 3 through 22 twice. So first, I don't care what this one is. I'm just going to figure out what x is, so I can look at it here. Same thing, multiply by 2, x equals 2. And now, I guess I can use either fraction, but if I can't make a nice clean rule from the second fraction to this fraction, I can always go back to the start and use that fraction to find my rule. But if I use this fraction, 6 times 3 is 18, 2 times 3, y equals 6. If I use the first fraction, 3 times 6 is 18, 1 times 6 is 6. So any of the fractions will work, but sometime, and I'll give you an example here on my own in just a second, you may have to go back to the initial fraction to find your rule because you won't have a clean clean things, such as, what if I had this? Well, we already know x over 6, it's 2, right? But what if I had y over 9? You'd be like, well, I can't get from here to here, right?
Yeah, go back.
So go back to here, and they go, oh, wait, just multiply by 3, y equals 3.
Yeah.
So if you would run into that situation, just take a step back, and that'll clear it up for you. Got it?
Yep.
I'll give you 2 to do, and we're done.
Wow, that's it.
I just made.
Yeah, see that? That's sad. I mean, you need.
No. It's not that spaghetti from the
No, I think it's. Then mine can icing. Wear your glasses.
because you're not right on the side. Walk, give it down.
Oh, yeah.
That's not.
Is that one your own problem?
Yes. Yes, it is.
Stars.
Yours is a star.
Smile.
You should know. You should know that. by now. Don't you?
I saw that they eat stars though.
So 38, and sure, whatever you want to call it, one there. So solve for n, solve for p, solve for v, solve for x, solve for z. And we done with this.
Easy.
Lesson 6.6 is learning how to simplify a fraction. Right.
Why is that?
Wait, why do we have to do this if we're in 6th grade?
Well,
That's gonna be a fun lesson.
right.
Number 9.
6.7, you'll learn how to turn mixed numbers into improper fractions and improper fractions into mixed numbers.
I know, but 4 and 5 does. You have to go back.
Right.
He was just talking about it.
Exactly. I wanted to illustrate that because it's
That doesn't have to go into that. That does though. 4 goes 4 and that.
right. You can always go back to the starting block if you can't complete your rule. The 5th grade book did a really good job of illustrating this, but the 6th grade book does a terrible job of doing it. So I don't know why. But.
But we should. I think Don is still in the cup.
Right. Who wants what?
Don and Brooke.
I want the 38.
You want that one?
Poopy goopy.
All right. Brooke, you all ready for it?
Yeah.
Okay.
Okay.
So how'd you figure get in and how'd you do it?
Okay, so 7 goes into 14 2 times, so 2 times 2 is 4.
That works for me.
And then 4 goes into 12 3 times, so 14 times 3 is 42, and then I got 12 and 42.
Yep.
So,
They are there. N equals 4, P equals 42.
okay, I'm back.
Good stuff. All right,
Okay, 9 goes into 27 3 times, so you multiply 5 times 3 and you get 15.
so V is 15.
27.
Yep,
And then 15 doesn't go in 20, so you have to go back
right.
to that, and 5 goes into 24 times, so then you multiply 9 times 4 and you get 36.
Yep, X is
And
36.
then none of those go into 63, so
Nope,
then you have to go
nope,
all the way back.
Back
9
again.
goes into 63 7 times, 7 multiplied by 7, and 7 times 5 is 35, so Z equals 35.
That's right. So every single one of these, you had to go back to the beginning block here to solve them. But they all had a clean whole number rule, times 3, times 4, times 7. Brooke was able to use her middle one to get to the end. Just multiply times 3. Could go back to the beginning, multiply by 6. All equivalent, all is good. I think that's good. Okay.
I should go run and get my books.
Yep, that's fine. You got it, Jackson. Yep,
Like
if you
and
need to get anything, that's fine.
Like and subscribe. We really need it. Yes, we really need it.
Get the other one.